We demonstrate COVIZ, an interactive system to visualize and explore patient cohorts. COVIZ is about forming and exploring cohorts of patients with respiratory diseases, using their demographic attributes, their health markers, their treatments, and pollution data. COVIZ is easy to use by medical experts and offers many features. First, it provides the ability to isolate demographics, health markers, and treatments, facilitating cohort formation. Second, it summarizes the evolution of treatments of a cohort into health trajectories and lets medical experts explore those trajectories. Third, it guides medical experts in exploring different facets of a cohort and generating hypotheses for future analysis. And last but not the least, it provides cohort comparison that is applied to multiple cohorts to compare their statistics and health trajectories. COVIZ relies on QDS, a novel data cube structure that encodes and indexes various data distributions to enable their runtime and memory-efficient retrieval. Additionally, COVIZ visualizes air quality data in the regions where patients live to provide explanations. Our dataset consists of patients with chronic respiratory disease. COVIZ enables the analysis and formation of cohorts interactively. We use filters to define a cohort, for example, females under aerosol therapy treatment in Grenoble. To execute that, we select all the filters in the user interface and then click on Create Cohort button. The system illustrates the correlation of markers with the cohorts as well as a common representation for the cohort. For instance, we observe that higher values of the fatigue marker in the cohort relate to death. We also observe that the progression of the sleepiness marker has been decreasing until late 2015, and then it increased again. Based on the cohort representation, we realize that the cohort is also heavily dependent on oxygenotherapy treatment. We can also conduct cohort comparisons. We want to compare the cohort of females under aerosol therapy treatment in Grenoble with the cohort of males in the same region and being under the same treatment. By selecting the filters in the user interface, we can create any number of cohorts and then perform cohort comparison. Switching to the comparison view, we can observe less variability in BMI values for the male cohort. The indexing mechanism of COVIZ contributes to both challenges of efficiency and having a clear view, meaning that not only QDS enables interactive performance, but also it aggregates values in different regions of interest and contributes to clear views. We also observed that 1/3 of the male cohort members employ continuous positive airway pressure treatment, abbreviated as PPC, which is not the case for the female cohort. We realized that while the female cohort systematically employ aerosol therapy right after the admission, the male cohort may start using it a month later. The patient data contained records of respiratory treatments in France. The integration with pollution data allows the correlation of respiratory treatments with pollution levels in specific regions. While often the large size of pollution data collection hinders their effective analysis, COVIZ employs an indexing instance for pollution data that enables an interactive exploration over different regions and in different granularities. COVIZ enables experts to set exposure windows and observe the aggregation of pollutant values in different regions. For instance, we set 2010 to 2011 as the exposure window and observed that the northeastern region of France was highly polluted then. However, we also observed that this effect is temporary, as the volume of nitrogen dioxide is significantly lower in the period of 2011 to 2012. COVIZ enables experts to justify their observations of extreme marker values in the patient data using pollution data. For instance, we analyzed the sleepiness marker and observed that the variance of this marker in the region of Vienne in France is higher than usual in the year of 2010. We also want to verify that the amount of the nitrogen dioxide pollutant has influenced the daytime sleepiness factor in this area. With an appropriate exposure window, we observed that Vienne was highly polluted then, justifying higher values of the sleepiness marker.